So now that this is up and running and deployed to AWS as well, I think I just quickly like to take a minute to explain why I really like using this stack and why I would use it if I was doing a new project, like a new personal project. Um, Firstly, like it's really cheap to run, which is important for me because everything here is running on S3, CloudFront, and um, Lambda. So the cost of running this site is essentially like if it's not being used, it's almost zero. And you only really start paying once you get a lot of users. And even within that, like you'd have to get a lot of users before you were really paying anything over like, I mean, even $10 a month, I would say on this stack would be a lot. So yeah, that's why I like using it for personal projects. And also just the fact that because we bootstrapped it using T3, it means that we get a lot of stuff like that's already being like, sort of usually the latest and greatest features of Next. And also if you're using like Prisma or Tailwind or something, all nicely working together. One thing I would note on that though is, by bootstrapping it with T3, it's cutting a lot of corners for us, but also it's important that you still understand everything that's being done there. So, if you are going to use the stack and you're going to use Tailwind and you're going to use tRPC and all the stuff that comes with the T3 stack, then I would say that it definitely makes sense to, learn all those pieces individually as well. And not just like, you are kind of throwing yourself into the deep end a little bit with how all these things work together because it's quite a lot of complexity, which is under the hood. So yeah, another thing which I really like about the stack, which I mentioned before, is the way that NextAuth is being leveraged to handle the authentication logic, and also how that works very nicely with the APIs from tRPC. For example, down here, we have this server component CRUD showcase where we can fetch the session using NextAuth, and then we can say if there's no user, then we just don't show anything, and then if there is a user session, then we can get the latest post. That means that if I go to my front end and I'm here not signed in, then I don't see any post messages. And as soon as I'm signed in, then I can see this protected part of the application. And if I were to maybe accidentally, put this query up here and try and access it when I'm not logged in, then I'll actually get when I sign out now, then I actually get an unauthorized error when I try and run this, because this is a protected procedure from tRPC, which means that it can only run if there is a user in the context. So this setup, although a little bit complicated, allows you to do a lot of very fine-tuned logic with regards to your user sessions, user on the client, user on the server, when to fetch data, protecting certain areas of your application, protecting certain functions that might, for example, like access the database and that kind of thing. And all of this can be contained in one solution, where on the server you can happily use API secrets, use access the database, and then protect how that can be called from your front end. The other thing that is really nice about this is, which I'm a big supporter of, is the type-safe APIs, right? So what I mean by that is, like, here we have tRPC, but in general, the idea of a type-safe API is just that you have a clear contract from the back end to the front end, and then you use TypeScript types to have compile errors about if you're trying to access properties or call endpoints that don't actually exist, right? So if I can show you an example of that, let me go to the code here. Let's say that we have this tRPC endpoint here. So if I immediately just go and go to api.post and I put a dot, I can already see all of the the functions that are available on my backend. And if I do hello.query and send in some text here, actually with tRPC, it's really powerful because you can even command click and go directly to the backend server function, which is defining this function. So if I, for example, come into here and we're saying like we need to send text and then we get a response, right? But let's say we also want to send something else. So I don't know, we want to send message as well, right? And then you can define using Zod what that has to be. So we have text, message, like this. And when I do that, then I can immediately see on the front end that I have a compiler error saying that I need to specify, it's going to tell me like you need to specify greeting. Of course, if I want to make that optional, I can do string.optional. Right, and now I don't have a compiler error anymore. Okay, going like this, you say, yeah, okay, so you need to specify message. And you see I get the IntelliSense, and my message is just going to be message. The same is true for the response. So what that means is if I come into my query, and even the refactoring works as well, which is very powerful. So if I, for example, come into here, and instead of greeting, it's going to be called like, I don't know, response. Right? I can refactor that, and you can see that already in my message down here. Then you can see this has already been refactored to response, right? And yeah, I mean, this is super powerful because it means that I don't have these issues where I'm going to have be calling properties that I think should exist on the back end, but actually don't. And it's all about reducing bugs, shifting errors left. So what would have been a runtime exception or a UAT ticket, like user acceptance ticket, is now a compile error. So what I mean by that is like if your backend team is going to, come into here and change this, they want to change anything like message to change it to something else, right? Normally you wouldn't actually spot this on the front end until you maybe do a release, or maybe it would get caught in like a end-to-end test or something. But here you can just immediately see the test as a compiler error. And even if you actually refactor properly rather than just renaming, you don't even get the error at all. So what I was showing before is like, if you actually were to come in here and instead of, just changing it like that, but you actually refactor symbol using F2, then you can see that immediately it just works, right? So yeah, this is a very powerful way of doing APIs. I think tRPC is great. And this is one of the benefits that you have when you use the TypeScript everywhere stack, is that, because your backend here is in TypeScript, it's very easy to, define those types once on the backend and then import them into the front end, and everything just works very nicely. So there are other ways of doing type-safe APIs. tRPC is a good one, which I've shown. If you have GraphQL, then that's also a good way of doing type-safe APIs, because GraphQL has like GraphQL CodeGen, where you can generate your types on the front end from the schema. And I would say that GraphQL therefore works quite well if you have like distinct back-end, front-end teams, and the back-end can like change the contract as they like, and then the front-end can kind of move over to that new contract as and when they're ready. I might use tRPC more in a project, well, obviously where I'm on my own, but also if I have teams where I have like, front-end, back-end developers are basically just all in one team and they're all full stack developers, then I might be more inclined to use tRPC because it means that basically you're kind of blurring the line between front-end and back-end, and your back-end call is essentially just a function, that happens to be on the server side. So but it means that if you go in there and you do make a breaking change, then you need to immediately know where to update that on the client. Whereas if you're using GraphQL, you kind of have more freedom for the backend team to maybe diverge, and then by defining the correct schema, the front end team can kind of catch up to those new changes in types. So yeah, for more like on this debate, I think Theo on YouTube is already a great resource here. Yeah, Theo has a great video on this where he goes into kind of more detail of the comparisons I was just talking about between tRPC and GraphQL. Highly recommend this video. And then another option for creating type-safe APIs, which I would definitely use if I don't have a backend in TypeScript, is I would use Swagger TypeScript API. So here is the GitHub repository for this. So essentially, when you're using this, what you're going to do is take the Swagger documentation, so supports like Open API 3.2. So one of these specifications, which is the Swagger documentation for your API, and it's going to use that documentation to generate types. So just like you can see here, we have this Swagger Open API spec, and that generates these types from that. So yeah, to recap, like I think, type-safe APIs are essential, and because otherwise you're just wasting a lot of time and you're going to create a lot of bugs. If I'm, within the TypeScript world, I would probably use tRPC or GraphQL, and there are trade-offs between the two. If I don't have the backend written in TypeScript, then I would make sure that that API is generating a Swagger documentation, then I would use this package to generate types from it.